Hello everyone, this is Group 1, and today we're going to talk to you about the potential, challenges, and the future of biofuels as a sustainable energy source.
Biofuels are a class of renewable energy that is specially derived from living organic materials commonly known as biomass. Biomass contains the stored chemical energy that plants capture from the sun via photosynthesis. Biofuel energy can be obtained from wood, landfill gas, alcohol fuels, crops, as well as animal manure and human sewage. The biggest movement coming from the current research and development is to process biofuels from cellulosic and algae-based resources. Biofuels are a lot more common than one may think. A few common forms of biofuels that we see every day are ethanol, which is cultured through the fermentation of plant sugars, and biodiesel, which is manufactured domestically from vegetable oils as well as animal fats. These two types of biofuels are only representative of the first generation of biofuel technology. The graph shown in this slide depicts the current use of biofuels in each transportation sector along with the change that needs to occur by 2075. Air and water freight transportation need to rely almost completely on biofuels by 2075 to significantly reduce carbon emissions by these two massive sectors. Now, just how big are these two sectors? Transportation is the biggest greenhouse gas emitter, being responsible for 29% of the total emissions. Coming in at a close second is electricity, which is responsible for 25% of total emissions. Biofuels have the potential to be an excellent alternative for fossil fuels for transportation and energy. The goal of biofuels is to obtain net zero emissions from the transportation and energy sectors. This can be achieved by the carbon in biomass, which is then converted to biofuels. Then the liquid biofuel is used in vehicles. These vehicles will then release a small amount of CO2 that will be absorbed by the very same biomass used for the biofuels. Coming up next is Becca to explain the potential for biofuels, and then Madeline will talk about the key audiences identified. Afterward, Pauline will discuss several opportunities for action, and lastly, Adrian will explain the barriers to action.
In 2019, 74% of U.S. greenhouse emissions resulted from burning fossil fuels. As Ian mentioned, the main goal of the development and use of biofuels is to decrease the emissions released by burning these fossil fuels. Replacing fossil fuels with organic matter is one way to obtain the energy needed to fuel the transportation and energy sectors. Biofuels release less CO2 into the atmosphere and can be classified as carbon neutral, as the carbon dioxide that is released when biomass is burned and converted to fuel is recaptured by this biomass again through the process of photosynthesis. Unlike fossil fuels, biofuels are a renewable source and they can be produced domestically. This would reduce our dependence on importing foreign fossil fuels. As advancements in biofuel generation are made, these potentials for the use of biofuels will only increase. First-generation biofuels, made from food crops, used food resources to generate fuel and therefore contributed to land use sources of increased greenhouse gas emissions, such as through deforestation. The negative environmental impacts of biofuel production has decreased as second and third generation biofuel production has developed. Second generation biofuels use cellulosic or plant materials to generate fuel, and third generation biofuels further reduce land use needs by using algae as the base material for fuel. As future generations of biofuels are generated, such as genetically engineered algae, and the process of biofuel production becomes more efficient, the adverse effects of land use and other waste production will decrease. The future for biofuels looks promising as an alternative to fossil fuels that is carbon neutral and is being streamlined and optimized to decrease its resource use and waste generation. Therefore, for biofuels to be used in an entirely carbon neutral fashion, further research has to go into its development and production. Madeline will now talk about the main groups and committees who will have an important role in the development and research into these biofuels.
Hi, I'm Madeline, and I will be speaking on the key audiences for this issue. Current governmental offices such as the Bioenergy Technology Office, or BETO, in the House Committee on the Climate Crisis are working on funding research in this area. One main focus of this committee is blending biofuel agents like ethanol into gasoline and the development of biodiesel. Integrating ethanol increases octane and helps cut down on carbon monoxide and other smog-causing emissions. Currently, the most common ethanol percentage is around 10%, and 97% of gasoline in the United States contains some ethanol. There has been recently a push for more 15% ethanol in gasoline. Republicans, like Illinois' Congressman Rodney Davis, are in favor of ethanol and biodiesel productions outlined in the Renewable Fuel Standards, or RFS plan, as it supports the farmers and industry, which is very prominent in the Midwest. Overall, Democrats favor biofuel research when considering economic risks or social benefits, but less so when considering political risks. However, recent actions by the Biden administration are debating changing this plan, which comes as a surprise to many. This is mostly due to large pushback from oil companies citing large economic issues. The common goal remains to cut down carbon emissions across both parties, but there uncertainty lies in the exact method and role biofuels will be playing.
In an attempt to address current energy security and climate change, we must urgently take the initiative to convert auspicious ideas into competitive and feasible solutions. In order to meet these goals, we must act quickly and efficiently in the present. Primarily, we must overcome scientific and economic challenges. We must develop a greater knowledge of plants, microbes, and other feedstock at their cellular and molecular levels, as effectively engineer their biological systems in an effort to increase efficiency and reduce conversion costs. We must develop new technologies required to sustain efficient biomass collection, production, and distribution. Examples include strategies for moving feedstock, collecting and storing biomass resources, and transporting feedstock from the field to biofuel refinery. Finally, we must seek greater collaboration with researchers, farmers and foresters, state governments, academia, and potential international partners. By the year 2030, we must have further refined the present strategies for biofuel production and distribution. We must develop more efficient conversion techniques to drive down the energy requirements for the production of various biofuels, as a common argument against biofuels, especially bioethanol, is that the amount of energy required to produce it is comparable to the amount of energy it generates. Therefore, the future of biofuels is highly dependent on their profitability. Currently, biofuel production is the most profitable in tropical environments where biofuel yields are higher per acre and input costs are relatively lower. Additionally, we should have developed successful public incentive policies to support the production and deployment of biofuels and encourage both local and international partners to take the investment risk. By the year 2050, we must aim to develop the most promising biofuels with the maximum potential. Biobutanol, for example, has a promising potential to become a future biofuel. We should also have made breakthroughs in certain biofuel production, such as algae biofuels, which, as of now, are still in the laboratory experimental stage. Most importantly, we must ensure that the biofuel consumption growth greatly exceeds the consumption rate of transportation fuels. To do so, we must meet the land requirements to increase biofuel resource availability required to make biofuels economically profitable. The profitability of the biofuels will allow us to undercut the continuously rising oil prices. Profitability in new technologies will continue to be the deciding factor of the future of biofuels. By the year 2100, we should hope to see highly developed specialized sectors dedicated to the production of advanced biofuels, paving the way for a reduction in operating costs. We should also hope to see that the widespread adoption of clean, renewable fuel alternatives has significantly reduced carbon emissions, especially in the transportation sector. It is of utmost importance that action be taken now to ensure that viable fuel alternatives are developed in conjunction with other environmental measures to reduce carbon emissions and impede climate change. Adrienne will now discuss the potential barriers to action.
Hi, so I'll be talking about barriers to action. So we already know that biofuels such as ethanol and biodiesel are used in our everyday lives, and first generation biofuels come primarily from food crops. Future sustainable development goals in biofuels aim to focus on third generation biofuels, which focus more on genetic engineering and decreasing the negative impacts such as land use. Some impacts from using biofuels that contribute to the action gap is that large-scale use of biofuels may contribute to deforestation and increase in food prices. Land use is also a major concern as production of first and second generation biofuels require a relatively large amount of arable land, which is not an appealing investment, especially to low-income areas. In the picture, we see how negative impacts have reduced from first to second generation biofuels, and how the pledge to use more third generation biofuels will have even less negative impacts. Future development of biofuel technologies should focus on minimizing competition with food production and land use, as more people would be in favor of an energy source that did not interfere with local or large-scale food production. To minimize the action gap between what has been pledged so far in the field of biofuels and what has been implemented, biofuel industry should focus on educating the public on how they can incorporate biofuels more into their daily lives. Industries and legislative bodies should collaborate on devising the most cost-efficient methods to implement biofuels while minimizing the impacts on industries such as agriculture. The picture shows an example of how microalgae, one type of biofuel, can be modified to be as cost efficient as possible. Implementing aquafarming and co-producing products and cultivation for biogas and wastewater are just a few ways that biofuel industries have devised to lower the cost of this biofuel.
As biofuel research continues and new generations of biofuels are developed, the totally carbon neutral goal of biofuels is capable of being accomplished. However, action needs to be taken now for any significant changes to occur. Further research into algae-based biofuels and other fourth-generation biofuels will help overcome land use barriers and decrease other negative environmental effects of biofuel production. Groups such as the House Committee on the Climate Crisis and the Bioenergy Technologies Office are taking action to fund and collaborate on developing next-generation biofuels. To minimize the action gap for the development of more efficient biofuels, it will be important for these and other industry groups to educate the public on the potential of biofuels. All of these challenges must be overcome so that biofuels can be available for global use, and at which time they will have a positive impact on both the global economy and the environment.
If you have any suggestions or recommendations, please leave them in the comments below.